This is the third part of this Module 2 test review. So now we're looking at number 11 where we're saying, is this a function? Yes or no? And we want to remember about a function is that for each x, I only get one y. This means when I put an x in, I'm only going to get one y back out. It would not be a function if I put x in and I get two different y's, whereas I can have the same y for two different x's and it would still be considered a function. So we see here we have -4 gives us 3, no problem. 3 gives us 2, again, no problem because these are two different x's. 3 gives us 5. So now we have an issue because here 3 gives us 2, but in this set 3 gives us 5. So 1x is giving me two different values for y. And that means no, this is not a function. The domain is the set of all the x values. So we look literally at every x value. We only write them once. I like to write them in numerical order, descending order. The range is all the values of y. So we have 3, 2, 5, and 1. Okay. All the values of x for the domain and all the y values for the range, but only list values once. Even if it shows up twice, you only put it once. Okay, so the next one is telling us it's a function, right? Because f of x, if you remember, is function notation, where f of x equals y, right? So this is function notation. It's a function of x. Okay, so f of x equals 2x squared minus 5x plus 3 when f is equal to -2. So all I'm going to do is take f of -2, and everywhere that there's an x, it now is -2. Make sure that you plug it in with parentheses. If you don't, you are much more likely to make a mistake, especially with negative signs. So here I have -2 squared will give me 2 times 4 minus 5 times -2 plus 3, right? That's order of operations. You do exponents first. Now multiplication. 2 times 4 is 8. -5 times a -2 is plus 10 plus 3. 8 plus 10 is 18 plus 3 is 21. So f of -2 is 21. If I wanted to write this as an ordered pair, it's f of x equals y, so the ordered pair would be -2, 21. So for f of 3, we're going to do the same thing. F of 3 equals 2 times 3 squared minus 5 times 3 plus 3. Make sure you're putting it in parentheses so you don't mix up your signs or anything like that. Okay, so exponent first. So 3 squared is 9 times 2. Okay, 2 times 9 gives me 18 minus 5 times 3 is a minus 15 plus 3. So 18 minus 15 would be 3 plus 3 equals to 6. Okay, so f of 3 equals to 6. Again, if we wanted to write it as an ordered pair, we would write 3, 6. So 13 says, state the domain of the following functions and use interval notation. And so we're starting with A, which has f of x equals x minus 5 over 3x plus 4. And hopefully you remember with domain, we were talking about what values, what numbers can I not put in for x? What am I not allowed to put in for x? And whenever you have a fraction, a rational expression, you cannot get 0 in the denominator. That's an issue. 0 in the denominator means that it's undefined. So I want to look at this denominator and say, when would this equal to 0? For what x would 3x plus 4 equal 0? And I solve minus 4. Okay. 3x equals a negative 4. Divide by 3. Okay, so when x equals a negative 4 over 3, that means I will get a 0 in the denominator. If I plugged in negative 4 over 3, I would get a 0 in the denominator, which is what I don't want to get. So my domain is every number other than negative 4 over 3. I can put in any other number as long as it's not negative 4 over 3. Because negative 4 over 3 is going to give me a 0 in the denominator, and that is what I don't want. So I can say negative infinity up to negative 4 over 3. I want to use parentheses because this number is not included. Union with negative 4 over 3, it's still not included, to positive infinity. And that's it. I just want a whole here at negative 4 over 3. I can put any other number in except for negative 4 over 3. So the next one, g of x equals 3x squared minus 4x minus 5. In the first one, we were talking about a fraction and getting 0 in the denominator. So in this one, is there any issue that you can see, anything that we don't want to happen? Hopefully you said no, because there's nothing I can put into this that's going to give me an issue like a 0 in the denominator or a negative under a radical or something like that that's not real. I can put any number in for x and I will get a number back out for y. So I'm negative infinity to positive infinity for this domain because there's no fraction or anything to deal with.